Hello all. Today we are going to learn about the topic transmission media. What is transmission media? It is anything that can carry information from the sender to the receiver. In data communication, the information is generally carried out as signals. You can see here the physical layer is transmitting raw bit stream through the transmission media to the physical layer of the receiver. The transmission media is of two types. It is guided and unguided. Guided is wired media. Examples are twisted pair cable, coaxial cable and fiber optic cable. Whereas unguided is there is no wired medium. It is wireless where the medium of communication is free space or air. The guided media can be defined as that which provides a conduit, that means a channel, from one device to another, which includes a twisted pair cable, coaxial cable and fiber optic cable. So what is a twisted pair cable? A twisted pair cable consists of two conductors or two copper wires, each with its own plastic insulation, which are twisted together. As the name says, twisted pair. I have a pair of cables, that is I have two cables which are twisted together. One of the wires carries signals to the receiver and the other is used only as ground reference. In addition to the signal sent by the sender on one of the wires, the interference or the noise and crosstalk may affect both the wires and create unwanted signals. So what is the purpose of twisting the cables? The purpose of twisting the cables is to reduce the crosstalk or the noise. Now you see, if we have wires parallel, if the wires are parallel to each other, for example I have a wire A and B parallel to each other, the EMI, that is the electromagnetic interference, will cut across the wire A and it induces a voltage, okay, and the electromagnetic interference will cut across the wire B and induces voltage, and this voltage interferes with the data signal and it may create unwanted signals. To overcome this, if the wires are twisted, the electromagnetic interference will cable, cross the wires or cut through the both the wires at the same time, where difference in voltages becomes zero and it does not alter the data signal. The data signal is not altered because the EMI or the noise is cutting the cable at the twist where the difference of voltages becomes zero and the signal is not altered. So more the number of twists per unit of length in the cable, more is the cable's quality. The twisted pair cable are of two types again. We have unshielded versus shielded twisted pair cable. What is shielded twisted pair cable? A shielded twisted pair cable has a metal foil over the cables. Over the two copper wires, we have a metal foil or a braided mesh covering covering. You can see we have a metal shield covering the two copper conductors. The metal casing, it improves the cable by preventing the noise and crosstalk. Like this it becomes bulkier and also expensive, whereas the unshielded twisted pair cable, you can see it doesn't have any metal foil over it, just the plastic sheathing that insulates both the wires. The every cable needs a connector, so the UTP is connector is RJ45. The registered jack 45 is a connector used for making connections with a twisted pair cable. The applications of twisted pair cables are used in local area networks and in the digital subscriber lines. The other cable is coaxial cable, which is a part of a guided media. The coaxial cable, compared to the twisted pair cable, carries signals of higher frequency. Coaxial cable, let us look at the construction of the coaxial cable. The coaxial cable has a central core conductor or an inner conductor which is enclosed with a plastic insulation sheath, then which in turn has an outer metallic wrapping which serves as both the shield against the noise and serves as the second conductor also, which completes the circuit. This outer conductor is enclosed in an insulating sheath and the whole cable is protected by a plastic cover. Likewise, we require connectors for connecting the coaxial cable to devices. So the connectors used for coaxial cable are named as BNC connectors, named after the person who designed it, Bayon Neil Conselman connectors. We have different types of BNC connectors, BNC T connectors and BNC terminator connectors. The applications of coaxial cable are they are widely used in analog telephone networks, digital telephone networks, widely used in cable TV networks and in Ethernet LANs. Now coming on to the third and the most important uh, guided media, which is fiber optic cable. The fiber optic cable is basically made up of glass or plastic and it transmits signals in the form of light. Optic means light. Let us look at the construction of the fiber optic cable. The outer jacket is made up of PVC or Teflon. Inside the jacket are these black things that you can see. Inside the jacket are the Kevlar strands that are used to strengthen the cable. Both the Kevlar Below the Kevlar, we have another plastic coating which serves as a cushion to the fiber. This is your fiber, and this plastic coating is serving as a cushion to the fiber. The fiber is at the center of the cable, and this fiber consists of cladding and the core. It consists of the cladding and core. You can see here the fiber has cladding and core. Two parts, the cladding and the core. The optical fibers basically use the concept of reflection to guide light through a channel. The glass or the plastic core is surrounded by the cladding, and this cladding is less dense than the core. This difference in density of the two materials must be such that the beam of the light moving through the core is reflected off the cladding, not being refracted. The propagation modes of fiber optic cable, the light, beam or the optical signal propagates in two modes, either the multi-mode or the single mode. The multi-mode is of two types, it is step index and graded index. Let us see each one of them. What do you basically mean by multimode? Multimode means you will have multiple beams of light traveling through the core in different paths. It's called as multimode. In multimode, we have step index and graded index. Step index refers to suddenness of change in the densities, because of which the signal gets distorted and contributes to a lot of distortion of the signal as it passes through the fiber. You can see the signal is getting distorted because there is a difference or suddenness in the change of densities. Whereas multimode graded index, in this we have less the core becomes less dense and the amount of distortion compared to step index in graded index, it is less. Then comes the single mode. In single mode fiber, we make use of a fiber of very small diameter than that of multimode, where we have very low density, and so the propagation beam is almost creates a 90 degrees angle and the propagation beam is almost horizontal. And let me tell you, the single mode fibers are much faster than the multimode fibers. The fiber optic cables also have connectors like a twisted pair and coaxial cable, and the fiber optic cable connectors are SC and SC connectors, subscriber channel connectors or straight tip connectors. Subscriber channel connectors are used for cable TV and straight tip connectors are used for connecting networking devices. The applications of fiber optic cable are that it is found in many backbone networks because of its high bandwidth and cost-effective nature. So in this video, we have learnt about the transmission media, in which we have learnt about the different types of guided media, that is twisted pair, coaxial cable and fiber optic cable. Thank you.